My people, hope you guys are doing well. We are on our last lecture in chapter 8. Okay, so I want to show you a couple of things before I get started here. I want to show you that I have posted a practice exam for this week. So you'll see there's one op amp. There's one with a constant source. By the way, this is not like the quiz where I only gave you one question by accident. Then you got a time dependent source. Then I grew a heart for some reason because I split up the second order differential equation. So one where you got to derive it, and then the other one I'll give you the first two equations, and then you got to go in and solve the rest of this problem right here. So just so you know, it's posted, and where it's posted at is you'll see here is that I opened up exam 2 module. There's a practice exam, and this is where you're going to find the second exam. Okay. So let's go back to where we were. And one of the things that we were doing here is that we were looking at problem 5, I believe that we were looking at. And this is where we got to. So let me share my screen with you so that we could get started there. So what you're seeing here is that it should look like this here. We had just completed the solution to example 8.5. And so what we were doing here is that we were looking for the voltage of the 8 ohm resistor, and you can see that the 8 ohm resistor is parallel to the cap, and the inductor. So we now have this solution here. And so now my job here is to interpret this, plot and interpret what's going on. So let's go do that. So here, let me set up here just a little bit, and then we're off to the races here. So let's look. So what do we know about the 8 ohm resistor? Okay. So what I want to do here is that I want to look at this guy, and I want to know the behavior of the 8 ohm resistor. So what do I know? So the first thing that we want to do here is that we know that at t equal to 0, we know that V8 of 8 ohms at 0 minus must be like this here. So we know that we have an open of the cap. The inductor is now a short, and then we have the 4 ohm, and then we have the 8 ohm right here. And here's the 4 ohm. And the way we're looking at this guy here is, remember, this is a circuit here. So we know that guy's a short. This guy's not on, so it's an open. So what I'm really seeing here is that this guy's giving me bad sign, minus, plus, and this is VC of 0 minus, which is minus 5 volts. So what this tells me here is that if I'm looking at the voltage across V8 at 0 minus, it's got to be the opposite of that. So right away, this tells us here that V8 at 0 minus must be minus of VC of 0 minus, which then gives me minus 5 volts. Right? It has to be, that guy has to be, well, it's got to be minus 5 volts. That's all I know. So I don't know about this double minus sign, but it's got to be minus 5 volts. So I got to be careful with that sign. Right? Because that's the only thing we know, is that it has the opposite polarity. So now, because this is a resistor, we expect a discontinuity. Okay, discontinuity because the sudden turn on of the 1 amp source, right? It's a dramatic change. So when I look at, so I should be careful here. Here's what I got here. And then what I'm seeing here is that VC, oops, not VC, V8 at 0 plus, we expect a discontinuity. So then we can see that the solution from up here, we can see that's got to be 8 minus 52 times e to the 0. And then sine of 0 tells me that's got to be 8 volts. Right? Clearly this guy goes to 0. And then another thing that we see here after 0 plus here is that if I look at V8 of infinity, well, clearly that exponential term is going to kill this thing. Doesn't even matter what that is. That guy has to be 8 volts. So we're really expecting something quite different than what we're seeing here. So if I start to plot this guy, the question is, what does this look like? The first thing I do is I punch it into my calculator. That's for starters. Okay. So what I'm going to see here, so if I start to plot this guy, what am I seeing? I'm seeing that this guy is 0. Let's say this is 0 volts here. I know this guy's gonna, so if I look at this guy, it's gonna, let's say that right here is my 8 volt value. So this is VC, God, I keep saying VC, V8 at 0 plus, that has to be 8 volts right there. And then down here, let's say right here, this point here is V8 of 0 minus. We saw this was minus 5 volts. You know what? I got to move this guy out of the way. So what I'm seeing here is that before t equals to 0, I'm going to have a constant current right there, or a constant voltage across that resistor. And then all of a sudden you have a sudden discontinuity jump all the way to 8. So the question is, does this guy dip down or does it go up above this thing? After 0 plus, does V8 ohm of T go up or down? And then what I did here is that I just picked one point. So we know it's got to have some type of smooth sinusoidal, type of behavior. So we got to be careful what we mean by, see, I can't really say whether this is sinusoidal because that exponential term. And so what we're going to see here is that what I'm going to try to do here is that I'm going to try to guess whether this guy is going to do what, whether it's going to go down like this or whether it's going to go up like that. I don't know the answer to that. So what's probably the most reasonable thing here is to calculate where, find some critical point, take the derivative of it and see whether I have a minimum or a max. So then the way I do this here is that I'm going to take the derivative and get a critical point. So if I do that, you could imagine here that I'm going to come in, I'm going to take S hat of V8 ohm of T. And then, of course, note that the first term that I get, remember, so I got 8 minus 52 times E. Maybe I should just write this out. So then this will be 8 minus 52 e to the minus 3t sine of t. So if I take this, then I'm going to get what? I'm going to get, of course, I'm going to get a 0 term here. Then I'm going to get 3 times 52. What's 3 times 52? 150. That should be 156. So this should give me minus minus, so I should get 156 e to the minus 3t times sine of t. Then I got to use the chain rule. So if I take the derivative of cosine, then I'm going to get e to the minus 3t cosine of t. And that guy's got to be equal to 0. So if I look at this guy, I could immediately say here, so I got to solve for the critical point now. So right away, what you can see here is you can see that the exponential terms cancel out. Boy, isn't that sweet? So now if that's the case here, you could see here is that I could form tangent. So if I take that over to the other side, I'm going to get tangent of t is then going to be 52 over 156. So this tells me that the critical point of this guy here is going to give me what? So if let me get my calculator out, because I'm going to get 52 divided by 156. God damn it. Me and calculators. This shit don't mix. So I get a third of a second here. So if I get a third of a second here, right? So that's my critical point right here, right? That's my critical point. So now that I got my critical point, then I'm going to substitute this back into. Now if I sub back into V8 ohm of T, what do I get? At T equal to 1/3, I'm then going to go in and I'm going to write this as 8 minus 52 times e to the minus, what is that, 3t divided by 3, right? That's what my no t, times 1/3. Then I'm going to get the sine of 0.33. Now if I check this number here, I should get something like this. I should get value of 7.89 volts. So that means here that I'm getting, right? That means this guy has to go up. So if I look at my plot here, so it has a maximum. So if I come over here, let me see if I can grab this guy. So if I come over here, okay, mouse, let's see if I can get this thing to work here. So if I come over here and I plot this guy, I know it's got to be going up here. So if I look at this guy, it's got to look something like this here. So then what I'm expecting is that this guy has got to come back to V equal V8 at infinity, has to be a volt. So then I know it's going up here. So then I look at this guy and it's probably going to do something like this here. And that's what my voltage looks like.
Hey, Carlos,
Yes.
I'm a little confused. So if it's under 8 volts, why would it go up and not down?
Carlos, if tan T equals 1/3, wouldn't T be arctan 1/3?
Oh, damn. Yes, that's I thought I did that, but apparently I
Which
didn't.
it's 18.4.
So T is then what? 18.4 seconds?
Yeah.
Oh man, I got to go back and change my numbers. Yeah, so obviously this is wrong. I never took the freaking arctan of this thing here, right? So what I should have done, which I did not do, of 1/3, and it should be 18.4 seconds. So then I got to come in here and put in 18.4 seconds, right? In this case, it's got to be 18.4. What is that number? Well, that's even gonna make it, that's gonna just give it a little tiny jump here, right? Because this guy is gonna dominate right here, right? This is a dominant term. That's gonna immediately bring that to 0. So I'm gonna say that this is just a little over 8. Now, what is that exactly? I don't know, but it's gotta be something like this here. Okay, somebody else has to do this thing because I'm getting some funky number here. So it's got to be 52 times E to the minus. Yeah, that thing's got to be tiny. Look at that. So the order of 10 to the 23. So this is going to be 8 minus something of the order of 10 to the negative 23. So it's taking a dip then. I see what you're talking about, Josh. I totally had the minus. No, but it's got to take a little dip, not a thing. So it's going to look something like this then. Something like that.
Yeah, when I plug that into Desmos, I get exactly 8.
Yeah, I mean, for that number of sig figs, but it's got to drop just a tiny bit. Right? You can't ignore the minus sign, but it's got to have some small dip. But of course you're getting exactly it because look at that e to the minus what? What is that? 54 or something? That thing is just a dominant. That thing's going to just kill this term off right away. But like I said before, what would I have done? I would have punched that into my calculator like ASAP. I wouldn't be trying to plot this thing by hand, but I'm just saying that that's one way to look at it. Okay, so let's go to the next one here. 8.6. So let's do this nice and smooth. Okay, here we go. So let's, from start to finish, let's go do it. So I'm going to start off by deriving the equation. Here I go, step 1. So what are we looking for? We want to solve for the 4 ohm resistor here. Again, I would go after the inductor current. Why would I go after the inductor current? Because if you look at this guy right here, you could see that the current of the inductor is the same as this guy. But that's the easiest way to do that. But I think we should start mixing things up and start doing, you know, maybe doing these problems, you know, different here. I don't know. Let's just do it this way. Okay, here we go. Should I stick with, we just did the inductor current. Should I stick to the inductor current or should I go after the capacitor? It seems to me like we should go after the inductor, but I don't want to keep doing the same type of calculations. So here we go. So at t equal to 0 plus, what's my circuit? Note that there's no 5-volt source. So what I have here is that this guy turns on. So I get 10 volt. I have my inductor, right? Here's my 4 Henry inductor. And then I have 2 elements in parallel. I have my 2 ohm and I have my cap. And then I have my 4 ohm. That's my circuit. So here I go. So I know that this guy here is my inductor current. And then clearly I have to have positive, negative here for VC. So let's go do it. So how am I going to do it? I'm going to apply KCL. And clearly, if I look at this node right here, you could see that the inductor current is going to split here. So here I go. KCL tells me to connect these guys. So then that tells me here that I'm going to get what? The current coming in is going to be the current of the 2 ohm resistor plus the current of the cap minus the current of the inductor has to be equal to 0. Now, I could see that the 2 ohm is in parallel to the cap. So then I'm going to come in here and I'm going to write this as 1/2 VC. Then this guy's got to be 1/8 S hat VC minus IL. And then if I clean this up just a little bit here, I'm going to write that this is 1/2 1 plus 1/4 S hat VC minus IL equals to 0. So I got my equation. Now let's go look at KVL. So I have to do a loop around the outside. So for KVL, the only way I can connect it, there's only one loop in the circuit. So I'm going to get this guy right here. So note that the 10 is going to be on the right side. So I'm going to start at the inductor here. So here I go. So this is going to be VL plus VC plus V4 ohm. Now remember, all of that equals 10. Now note that the 4 ohm and the inductor are in series. So then if I start to write this, I'm going to write this as VC. So here I go. Then this is going to be 4IL plus, look at the inductor, it's a 4, so this has to be 4S hat IL. I'm going to combine the inductors now. So this is the inductive term that is. So then this is going to be 4, 1 plus S hat IL, that equals 10. So now I have my 2 equations for KVL and KCL. Let's write it up. So if I write this up, what am I seeing here? I have one term, all my VCs. Now I have my inductor term. And this is minus 1. So I have this, and this is going to be VC, IL. Let's look at my sources. This will be 0, 10. So now that I got that, I'm now going to go in and think about my solution here. So then this tells me here is that this is going to be d hat operating on IL. So now if I look at this thing, I need my constant term. So remember, here's my IL term. So that's where I'm going to replace that. So I'm going to get 1/2, 1 plus 1/4 s hat, 1. I'm going to get 0. I'm going to get 10. So if I take the determinant of this, look at that. The s hat term operating on 10 is 0. So I'm going to get 1/2 times 10. So it should give me 5 and 0. So this is 5. Okay, now let's go calculate d hat. So if I calculate d hat, remember, this is my determinant right here. So let's go calculate that. So I see I get a 1/2 times a 4 should give me 2. So I'm going to get 2. Then I'm going to get 1 plus 1/4 s hat. And then I'm going to get 1 plus s hat. Minus 1. So I'm going to get a plus 1. And this guy is operating on IL. Now remember, on the right side is 5, but I'm going to wait to put the 5 in. So now let's start dealing with the algebra here. So what I'm seeing here is that I'm going to get 2, and then I'm going to focus on the square term. So then that means I got 1/4 times 1. So then I'm going to get 1/4 s hat squared. So now I got to add the 2 s's. So then I'm going to get 2 times, now let's check this guy out. So I get 1/4 times 1 and 1 times s hat. So I should get 1 plus 1/4 s. Okay, and then my last term is 1. So I got 2 times 1, so there it is, plus 1. So if I clean this up a little bit, let's write this out. So I'm going to get 1/2 s hat squared. So this guy's going to give me 5/4 times 2, which will give me 10/4, which is the same as 5/2. But I'll leave it like that for right now. And then I'm going to get 2 plus 1 should give me 3. This is on IL, and now this is 5. So to put it into proper form, I'm going to multiply everything by 2. So then I should get s hat squared. So let's be careful here. So this is 5/2. So this should give me 5 s hat. And then I get 3 times 2 will give me 6. So I get IL, and this is 10. Let's see how I did this time. Okay. So now let's go do the check. So the check clearly tells me that IL of infinity, which is our constant b, this should tell us that I'm going to get 0 plus 50 plus 6b equals to 10. So therefore, this tells us that b should be 10/6, which is the same as 5/3. Let's go check this out with the circuit. So if I go look at my circuit here, at steady state, the inductors are short, the cap is an open, right? So at steady state, I got my 10 volt, I have my short, I have my open, I have a 2, and then I have a 4. So here's my 2, here's my 4 ohm, and I could see that this is also the current of the inductor at infinity. And we could see here that from Ohm's law, this guy has to be equal to what? 10/6 amps. So guess what? These guys match up. So that's a simple check. So we're looking good here. So Let's go look at this guy. So now I got that. So now the thing that I got to do here is that I got to go look at my, I got to go get my general complete response here. So now we want to determine the general complete response. Okay, so let's go look at this thing here. So if I look at this guy, we know here that if I look at my characteristic equation, looks like this. Slash roots, what does it look like? Well, it looks like this. So it's got to be s squared plus 5s plus 6 equal to 0. Now, I think these roots are easy. They should be 3 and 2. This implies here that I can write this like this. So the solutions here is going to be S1, and S2 has to be -2, -3. The fact that these are real and distinct tells you that it's overdamped. Let's go calculate that. So if I go calculate this thing, this tells me that the the current IL of t should then be, should give me a1 e to the -2t plus a2 e to the -3t plus my force response, which should then be 5/3. So now I have my general response. So now my job here is to go in and to do what? Go get the initial conditions, right? We got to get the initial conditions, and then we got to apply it. So now I typically do step 3 and 4 together. So I'm going to determine initial conditions and apply them to get A1 and A2. Let's go do that. So I have to go get the 2 first order equations. Let's go get them. So I'm going to just highlight these guys and just bring them down and then clean them up a little bit. So the first order equations are these guys now. So if I have these here, so here's what I get. So you could see that I have my KCl and my KVL equations. So if I'm looking at this, which one am I looking for? I'm looking for the derivative of the inductor. Okay. Okay. And you can see here that the one that has the derivative of the inductor is this guy. And this is what I always said, call it equation 2, since our variable 2 would be that. So I know how to get that guy, but I have to go do the other thing first here. Just setting this up here. So now what we're going to do here is that we need to go determine VC of 0 minus and IL of 0 minus. Okay. So if I look at my circuit, I got to go get that circuit here. Let me go grab that. And it looks like this. So here's where it's easy to make mistakes. I can only tell you from my experience, you guys, I'm sure, make less mistakes than I do. So if I go in here and I look at this guy, what am I really seeing here? Well, what I'm really seeing here is that this guy doesn't exist, but I have a 5-volt source here. So what I'm seeing here is that I have a short for the inductor. I have my 2 ohm. I have an open for my cap. And then I have a 5-volt source here. So what I'm seeing here is that I still have my 4 ohm right here. So what we're seeing here is that for this 4 ohm, I know that my inductor current, according to our problem, should be going in this direction right here. So clearly what I'm seeing here is that the cap must be the same as the 5-volt source here. So if it's the same as the 5-volt source, then all we got to do here is that we got to go in and calculate what that inductor current is here. So let's look at that. So right away, what I'm seeing here is that I'm seeing this here. I'm seeing here that VC of 0 minus, which is of course 0 plus, has to be 5 volts. But look at the polarity of the 5-volt source and look at the direction of the inductor current. They're opposite. So this tells me here is that the 4 ohm at 0 minus must be the inductor current at 0 minus. So it's really the current of the 4 ohm resistor. So if I use Ohm's law, that should be the voltage divided by the resistance. So it should be 5 over 4, but they're an opposite polarity right there. So right away, I got my my values right here, right? So now I'm going to go determine S hat IL of 0 plus. And you could see equation 2. So what you're going to find here is that, look at my equation. I have VC of 0 plus equals 4IL of 0 plus 4 S hat IL of 0 plus equals 10. Okay, that's a little bit too messy. Okay, that's what I'm seeing right there. So now what I want to do here is, of course, my goal is I got to solve for this guy right here. So you know what? I got construction outside my window. So I'm going to go close some doors because they're going to start hammering here pretty loud. Give me a second. Okay. So now what I'm going to do here is that I got to move this to the other side here. So look what I got. This guy right here, we said is, right? So this guy right here is 5 volts. This guy is 4 times minus 5,4. And you could see that these two terms are going to cancel each other out. So these two sum to 0. So then that tells me here is that S hat IL of 0 plus should be 10 over 4 or 5 halves. So I now have my other initial conditions. So I have my initial conditions right here. So let's go apply it then. So now I'm going to apply these initial conditions to IL of t to get A1, A2. Here I go. So then I have IL of 0 plus, should then look at my solution now. my solution has A1, A2, right? So I should get A1 plus A2 plus my constant here, which is 5/3. Now let's do S hat IL of 0 plus. So I got to take the derivative of that guy. So look what I got to get. I'm going to bring down a -2. I'm going to bring down a -3. Obviously 5/3 is 0. So then I'm going to get -2A1 minus 3A2. And this guy has to equal, according to this, 5/2. Okay, so I got to go calculate this little determinant here. That means I'm going to set up a determinant. So this guy's going to be, look at the minus signs. I'm going to multiply the minus signs out. So I'm going to get, so look at, just to make sure that we're all clear, I'm going to write a little matrix here. So then this is going to be 1, 1, 5/3. This is going to be 2, 3, and this guy's going to be minus 5/2. So let's go calculate A1. So A1 is then going to be what? I'm going to replace the 5/3 and 5/2 with the A1s. So then this should be 5/3 minus 5/2. And then this should be 1, 3. Then I got to take the determinant of the cofactors, which will be 1, 2, 1, 3. So then if I look at the denominator here, it's going to be 3 minus 2. So I'm always going to get 1. So it's really this factor right here. So I'm going to get 5/2 times 3. So this should be 5 minus minus plus 5/2. So this should give me what? That should be 7.5.
Carlos?
Yes.
We're missing a value.
Yeah.
What am I
for
missing?
IL of 0 plus, that whole thing should be set equal to the initial condition that we got, which was negative 5/4.
Is it not 5/2?
No, sorry, the first
Oh.
one.
Oh, damn. I
IL
wrote the
0
wrong
plus.
one. So this is minus 5/4.
No, I think the first one, right? The
Is it
Initial
5/2? Did I
condition.
not have 5/2? So what are you
Yes.
talking about?
The first equation, the IL of 0 plus, we didn't set it equal to A1 plus A2 plus 5/3. We forgot.
Mira, there you go. So what did I get? I should have gotten minus 5/4. Okay, thank you for the help. You're absolutely right. So if I look at this guy should then be what? Minus 5/4 minus 5/3. So that's got to be what? 5, is that 5/12?
Yep.
Okay, so that should be negative 5/12. So then I got to come back here and I got to put this as 12. So let me clear this up a little bit. So this guy should be 3 minus 2, and this should be 5/3. I mean 5/12 times 3. That should give me 5/4. And then this should give me minus 5/2. So I should get plus 5/2. So this should give me, is this 15/4 divided by 1? And then I have A1. So we could do this a couple of ways here. We can already see that I could then go in and solve for the second matrix, or I could just plug this guy into here and get this. You know, there's lots of ways to do this. I'll do it the matrix way because I think it's going to be faster. So now I'm going to replace the constants with the A2 term. So I'm going to get 1, 2, then I'm going to get minus 5/12. And then we already know the denominator is 1 already. So then this has to be minus 5/2. Then I'm going to get minus minus. So then this is going to be Look at that. That's got to be 5, 6. So this is really going to be what? This should be 5, and this should be 1, 6 minus 3, 6. So I should get minus 2, 6, which will give me a third. So I believe this should be 5/3 for A2. So now I got my initial conditions. So now I'm just going to come up and I'm going to substitute it into my equation. So now the solution, the complete response of IL of t is then going to be IL of t A1, so it should be 15/4 e to the minus 2t minus 5/3 e to the minus 3t. And then my constant term, what's my constant term? Is that 5/3? So now this is what this guy's going to look like here. So now let's go study this guy here. So now what I want to do here is that I want to plot. We're trying to get the 4 ohm resistor, right? If we're trying to get the 4 ohm resistor, we said that it's in series with the inductor. So it's got to be 4 ohms, which should be 4IL of t, and interpret. So the first thing that we should see here is that we expect a discontinuity. Okay. So if we expect a discontinuity, that means when I look at this guy, we're not going to see one. Right. So even though,
Hey, Carlos,
yeah,
could we take a look at negative 5/4 minus 5/3 again? Because
did I get that wrong?
yeah, a couple of us are realizing that that should be negative. Oh, well, I'm getting negative 35/12.
For this guy right here?
No, up top right of your screen.
Oh, for A1?
Let's see. Can I annotate on the screen? This right here.
What is that? What are you getting?
Like if we just do some algebra, we get 5/4 plus 5/3 equals 5/12, which is two things that are
I
greater.
subtracted instead of
Yeah.
added them.
Two things that are greater than one ending up as less than one.
Yes. So I have a number error.
So that's
Should be negative 35.
negative
12ths, yeah.
35.
So this should be negative 35/12.
Yeah.
So what did you get for, did anybody calculate A2?
We didn't work it that far yet.
Okay, so then let's go to here. So if that's, so then let's calculate this. So this should be A1 plus A2. And this should be,
Wait,
this
A1
guy
is
is going to
35
be
over
what?
12.
5. So I get 5 plus, this guy should be, was it 3?
Oh, yeah,
plus 4? It
Carlos.
should be 7/12. Right? So this should be negative 35/12. So then A2.
But Carlos, A1 wasn't just the negative 5/12. It was the
No. But no. Oh, I thought that was A1. Oh, my bad.
yeah.
So-
It has to go through the whole determinant.
Yeah. So then I think we have no choice but to do that. So then I'm going to cross this out and I'm going to move down. So if I move down, I got to get that determinant. So then I should have, so then when I look at my equations here, I should have A1 plus A2, and this guy should be minus 35/12. And then if I look at this next one, I should have minus 2a1 minus 3a2. And then this guy has to be 5/2. So then let's go do this here. So then I'm going to get 1 minus 2, 1 minus, nope, let's take the minus sign to the other side. So then there should be minus 35/12, and this should be 5/2. So let's go calculate A1. So then A1, we already saw that the determinant is going to be 1. So then this should be minus 3/2, and then this guy should be 1, 3 divided by 1. So then this should be minus 35, 12 times 3, minus 5/2 times 1. So if I look at this thing, this is going to be minus, so it's got to be 35 divided by 4. And then this guy should be 10/4.
Carlos,
Carlos, we
What?
dropped a negative sign.
Why?
When you moved the negative sign over here, it didn't end up over on the right side in the next step.
Okay.
So
thank you.
this should be negative.
That should be
this-
negative.
This should
Perfect.
be positive.
So let's put that negative right there. So then that should be positive. So then let's clean that up. So then this should be positive. So then that means here, and then this is minus, and then this new sign should be plus. So then this should be minus 25 divided by 4. And that should be A1. So now let's go. So if I now solve for A2, I know that A1 plus A2 minus 35/12 should be that. So then that means A2 is then going to be minus, so it should be 35/12 plus A1. In this case, A1 here is then going to be minus 25/4. So I'm going to get a subtraction between these two. So then this should be minus 35/12 minus, and that should be 75/12. So that gives me a constant of 40, right? Positive 40/12 for A2. So now I have A1 and A2, assuming no more algebra errors. So that means then the complete response is then going to be IL of t. This should be minus 25/4 e to the minus 2t plus 40/12 e to the minus 3t. And then that other constant, what is that other constant? It is 5/3. So now that I have this thing, I want to go plot this guy. So if I go and I plot this thing, what am I expecting here? Which is the same as 4IL and interpret. So what we see here is that we expect V4 ohm to have a discontinuity. But it will not happen. And the reason why is that V4 of ohm is proportional to IL of IL, and we know that IL cannot have a discontinuity. So when I'm looking at this thing here, we're seeing here that V4 ohm of T should be 4IL. So if I now multiply everything by 4 here, I should get minus 25 e to the minus 2t. And if I multiply that by 4, I'm going to get 40 thirds e to the minus 3t. And then I should get 20 thirds here. So if I'm looking at this thing, this is my complete response for the 4 ohm resistor here. So now that we know that it's not going to be there's no discontinuity here, what am I seeing with the 4 ohm resistor here? Now this is going to be the real true test, whether we get this, whether this is right or not. So the first thing that I would look at is I would look at something like this. What is 4 ohm of 0 minus? And it should be the same at 0 plus. Now so when I look at this guy here, let's look at the circuit at 0 minus here. At 0 minus, if I come in and I look at that circuit again, let me go get that circuit again. So if I come in here, what did I see here? I see that this guy right here should give me, here's my circuit right here. And so when I'm looking at the circuit at 0 minus, again, there's no 10 volt source. The inductors are short, and the voltage across this guy should be 5 volts because everything's in parallel. So at since all elements are in parallel, the voltage across the 4 ohm resistor should be 5 volts. So I'm saying here that this polarity here is plus, that's minus. So note that that polarity is going to be different than what it is when we have that 10 volt source in here. Let's go look at the solution here. So if I look at the solution, they should each give me the same value. So then this has to be, so at 0 it should be minus 25 plus 4 thirds plus 20 thirds. Wow. Let's see if this is actually 5 here. Let's make sure that my numbers are right here. So I'm getting 60 thirds. Look at this. Minus 25, that gives me minus 5 volts. That's the biggest check right there. So that's a huge check. So that this implies here, right? So this is proof here that I didn't put a minus sign here, but I was talking about it over here because we're expecting the current of the inductor to be going like this. That's why there's a minus sign here. So now that is a huge, huge check here. Now, the other thing that we should look at here is what happens at t equal to infinity. So I'm going to have that V4 ohm at infinity. Clearly, all the exponentials go to 0, so I should have 20 thirds volts. So now we can set it up here. So now if I look at this guy, what am I seeing here? Well, I know that it's starting out at minus 5 volts, right? So I'm seeing the voltage of this guy come in to this point right here, and this is V4 of 0 minus should be minus 5 volts. And then it's got to jump up to 8 volts here. No, not 8 volts, but it's 20 divided by 3. So then if I look at this guy, I'm seeing that, let's say that this is the value right up here. This is the voltage for ohm at infinity should be 20 volts. So then if I look at that curve here, it's overdamped, so it's just probably gonna, how am I gonna, I don't know, how's it gonna look here? Well, I'm assuming that it's gonna have some type of like little peak here. So I'm assuming that it's probably gonna do something like this here. Something like that. Now, I should be careful here. I don't know whether there's a peak here. I'd have to take the derivative to see if there's a peak there. But the overall shape should look like an overdamp that takes a fair amount of time here. So then this solution here should be V4 ohm of t is then going to be, what is it? Minus 25 e to the minus 2t plus 4/3 e to the minus 3t plus 20/3. So to really check if there's a peak here, we must take this guy and set it to 0 to get the critical value here. So if we do that, then that means I got to go in and take the derivative of this term. So if I do that, note that that 20/3 term is gone. So then that means here I'm taking the derivative of this guy, and then I'm going to get minus 25 times, I'm going to bring down a minus 2 plus 40/3 times minus 3 e to the minus 3t. And then, of course, that thing is 0. That's my critical point right there. So then this means here that this guy here should be what? It should be 50 e to the minus 2t. And then this guy right here should be, or is it minus 40 e to the minus 3t? And then we could sort of like isolate terms here. So then if I solve the solution here, you could see here that this is going to be what? So if I have, right, so this is, so if I bring e to the 3, so I end up doing this here. So all I'm going to do is I'm going to divide both sides by e to the 3. So then this gives me here is that I'm going to get e to the 3t minus 2t should then be 4/5. So now this is really e to the t equals 4/5, which then tells me that this guy has to give me, I have to take the log of this. So then t is then going to be the log of 4/5. Now I don't know what that number is, but that will tell us whether we have a peak there or not. So if I clear my calculator, then I'm going to go in and I got to get the log of 4 divided by 5. So then I'm going to get a value. Ooh, I don't like this. This is a negative number, right? Because this is less than 1. This is less than 1. Which means that I get a negative time. So I'm thinking that this solution is not looking like this. It's probably just going down something like this here. And probably there's a peak somewhere over here. So I wouldn't be plotting the peak. So I'm very positive that you're not going to see any peak on this side. But what's really the right way to do this thing? I would go in and I would literally plot this in like my calculator or Wolfram Alpha or whatever program you use. But that's the way I would do.
Carlos?
Yes.
So if it does peak, and by the way, I checked it on the calculator, and yeah, you're right. It peaks before the 5 volts. It's down, then continues like we kind of drew. What does that mean if it peaks beforehand?
Well, that's not a realistic part of the solution,
Oh, I see.
right?
Yeah.
I mean, we just have a function that looks like this, but it
Hmm.
doesn't, but it's not actually behaving that way after the
Okay.
switch is thrown.
So that back part isn't actually, that's not what the circuit's actually doing.
That's not what the circuit is actually doing.
Okay, cool.
That ends that chapter.